In the last slide, we learned what was work, and we said that the work was a product of force and displacement. Work was done when an object is displaced by a force. Today we will learn what is energy. Energy and work are very interconnected. Energy is the capacity to do work. If an object can do work, it is said to have energy. So the amount of energy possessed by a body is equal to the amount of work it can do when the energy is released. So if an object can do work, it is said to have energy. If an object is unable to do work, it has no energy. Now the SI unit of energy is joule, just like that of work. Work and energy have the same unit, and that is joule. So we have to remember work and energy have the same unit because work and energy are interrelated. Energy is a capacity to do work. Here in the first picture, we have a fast moving cricket ball, and this cricket ball, on hitting the stumps fall off. It is able to do work. Hence the cricket ball has got energy. And the kind of energy here, we call it kinetic energy because it is a motion, it is a velocity of the ball that helps it to move. So this is called kinetic energy. In the second picture, we see a hammer that is raised, and the raised hammer drives the nail in the wood, and that means the hammer is able to do work. And why was it able to do work? Because it was raised to a certain position, and the higher it is raised, you find the more work it can do. Such energy possessed by a body due to its position is called potential energy. But the fact is, the hammer has got energy because it is able to do work. If you have a hammer that is lying on the table or it's lying on the floor, it's unable to do any work. In the next picture here, we see a compressed spring in this third, and this compressed spring, when it is compressed here and released, it pushes this object. It is able to do work. So compressed spring can move an object. And why? Because we change its shape. This change in configuration or change in shape, it's able to do work. So such energy is also called potential energy. So in this slide, we learned what is energy. Energy was a capacity to do work. When an object can do work, it is said to have energy, and the energies are of different kinds. We have the kinetic energy, the energy possessed by a body because of its motion. Here in the second, we had potential energy of the hammer because of its position, and in the last, we had the potential energy of a spring because of its shape. We'll now learn about kinetic energy. It's energy possessed by a body due to its motion. Examples of a kinetic energy is like a flying arrow. So you can see here this flying arrow. It possesses kinetic energy because of its motion. Then a man running will also possess kinetic energy because of his motion. Blowing wind is an example of kinetic energy. When the air moves, when the wind blows, it possesses a lot of kinetic energy. In fact, a sailing of a boat with sails, the blowing wind has as much energy as to push a boat with sails. Then here we have a car, a racing car, a moving car, also possesses kinetic energy. A bullet, here a fired bullet, a firing of a bullet, kinetic energy. Then here in this example, we see a bird, a running bird, will also have kinetic energy. All these objects possess energy because they are in motion. We'll now do the derivation of kinetic energy. For this, let's consider a body and let the mass of this body be m kg. Let its initial velocity be u meter per second. Its velocity then changes due to a force. It experiences a force, and the final velocity is v meter per second. Time taken to change the velocity, let it be t second. Now, to change this velocity, we require a force. Let the force acting on the body be F, and because the force is acting on the body, there is an acceleration, and let the acceleration on the body be a meter per second square. Let's go over it again. Consider a body having mass m kg. It has an initial velocity of u meter per second. The velocity then changes to v meter per second. The time taken to change this velocity is t seconds. There is a force F newtons that acts on this body, and hence there is a change in velocity. And since there is a force, there is an acceleration of a meter per second square. Now we know work done on the body equal to force into displacement. By Newton's second law, the force is given as m into a. So Newton's second law says F equal to m into a, and that's what we have substituted, into displacement s. So we have substituted for force. Let us substitute for displacement. According to the equations of motion, so in equations of motion, we know that v square equal to u square plus 2as, which means v square minus u square equal to 2as. And if I want to find the value of s, it will be v square minus u square over 2a. So this value of s I am going to substitute here. So we know this was force was m into a, and for s I am now going to put v square minus u square over 2a. This a and this a will cancel out, and what will now remain is work equal to m by 2 v square minus u square. So this was work. We'll just rearrange. So we have half m v square minus u square. But what if the object starts from rest? If object starts from rest, we write u equal to 0. Now the work will now become half m v square minus 0 square. So work is half m v square. Now all this work that is done is converted into kinetic energy. So in the next step we'll say work done is equal to kinetic energy, because energy is a capacity to do work. So we can say kinetic energy equal to half mv square. There's another point to be noted is we saw that work equal to m by 2 v square minus u square. So if I open the bracket, first I'll rearrange half m v square minus u square, which is half, open the bracket, half mv square minus half mu square. Now half mv square, this half mv square, since v is final velocity, this is final kinetic energy. So for this I'll write final kinetic energy, and here is u square, so this is minus initial kinetic energy. So work done can be also written as change in kinetic energy. Work done is equal to change in kinetic energy. But it is important to remember the formula for kinetic energy, half mv square. So the factors on which kinetic energy depend on two factors. One is the mass of the body and the velocity of the body.